Hello, ladies and gentlemen, boys and girls. My name is Octoman, and this is a tutorial about how to save and load using binary files. So, let me talk about pretty quick what we are doing here. So, at first, we want always save data, meaning when we are on a playfield or when wherever we are with our character, wherever we have an inventory system. We want to save and load data as secure as possible, I would say. There are several possibilities to do that, but binary files are probably the easiest one in case of security. It's because these are going to be, binary files, so you cannot directly read the content which is inside this binary files. That's a difference, for example, to player prefs. So the usual player prefs can be rather unsecure since you can just open your regedit, for example, in the Windows, and you can just find these files and you can change the content inside. What does it mean is, meanwhile, you are able to go to these prefabs, you are absolutely not able to secure them, except you're gonna write some encryption something. There are also some assets which are providing this encryption already in player prefs, but on the other hand, if you have to store like 100 floats, it's going to be extremely expensive in case of CPU time, and it slows down like everything. So with a binary file, you can avoid that because you're only, well, most of the time, you are only writing one file, one data file, into that binary format. We're gonna check that out in just a sec. And then you are good to go, meaning you only write once, you save CPU time, you save whatever, a different time, just to make stuff, let's say, more efficient. So, what I want to do today is I don't show you how to create games. I show you just how the saving is going to work with this little example over here. So in my example, I have these blue cubes, which later on are just stones, and I want to store the positions and probably a behavior of these stones, like wherever they are currently in this play field. So, for example, you design a level and you have something like that. You want to store the information like that. Where is that cube? Where's the player? Where is an object located, which you probably have dropped somewhere? You want to have a connection to all these blocks or stones in this case, and you want to store them somewhere, or you want to at least request them from somewhere so you can store its position and its behavior, if there is one behavior. And this is the only thing. It depends on, once again, what type of game you are doing. For example, let's assume these blocks can be moved later on, like left and right, up and down, in a four-way based movement based on the grid. And the goal is to bring that blocks position to this green squares over here. So these green squares are basically the goals, but that are not important because once again we are not designing a game at the moment. We are more like trying to figure a way where we can store the information about these blue blocks, like 1, 2, 3, and store them. So later on, when we are, let's say, assume we want to load wherever, or we want to save wherever our blocks are, and we want to reload this content like these positions whenever we are like having more time to play or continue this level, then we are actually able to do that. And we read and write that data into binary or from binary files, and we store them in a binary file, so we can easily later on just reload or just load a level in this case. How do we do that? Okay, at first we need several scripts which are taking care of getting the data from the blocks, or at least we gonna need a connection to these blocks somewhere. I created an empty game object, which is the game manager over here, and I want to have a connection to all these three stones, depending on how big and how much they are in the playfield. I want to keep a connection to them, for example, with the game manager. So what we just do is we connect the three blocks to the game manager, but not as child, which would also work, and then get the connection automatically, or just find them through the scene and see where they're currently at and storing that the relevant data somewhere, like in a list. But before we can do that, of course, we need to create a script. There's some rest of the other tutorial. I'm gonna get rid of all these pretty quick. So I'm gonna delete those. Okay, so you have your scripts, you have your systems, everything is good to go. And what I need to do is I need to create a new C# script. I'm gonna name it Game Manager. And once this is done and running and open, you can see whenever you are in Unity 2K18 and over, this should be some kind of gear symbol to find it easier, which is doing stuff for managing games, like taking care of if we have won or lost and all the other stuff. But once again, we don't go into that design at the moment. So next thing is I want to create a list, or best way is a list. We can also use arrays, but we have to override and resize them the whole time, which is, I don't like that. So it can be a private list, can be public list, doesn't really matter. For debugging purposes, we're gonna yeah, take a public list over here, and where I want to store like all game objects which we have in the scene. Once again, we can do that also automatically by having everything based on the child of yeah, the game objects we're gonna have here. So we want to have that. We want to name it maybe stone list, and it's equal to, and now we yeah, we initialize that as a list of type game object open close parentheses. Of course, make sure you always have that in triangle brackets over here, and you're good to go. So in start, we want to make sure that we get the information where of these game objects. So where are they, or actually the complete ones. So we can basically at start we can do three things. We can drag them in by hand, like the usual process you probably know already. Maybe we're gonna do that to simplify the process. I'm gonna drag the game manager in here, and we have our stone list in here. And what we can do is, meanwhile we are locking that on the bottom, on the top right, we can select all these three stones and bring them into the stone list. So that's the easiest way to know everything about the stones in the game, meaning we now know everything about its transform. We know its position, where it's currently at. We know its scale. We know its rotation, and every related yeah, object. Somehow this is wrong here. I need to put it. Oh, I locked it, so never mind. So we know everything about that stone, and we know everything about its renderer component, its mesh, and its box collider, and all the other stuff. Even if there are later way more components on it, we always know about them. And that's a cool thing. Now we might want to think about, do we want to have some kind of ID on the stones? Do we need that? Well, depends once again on the game. Like for example, this is a specific colored stone with a specific ID, and you need to bring it only here. Then you're gonna use some ID system. Otherwise, I don't think we need that. Anyways, this is also not part of it, of the tutorial. We want to go into the binary formatter, right? So now our game manager knows everything about the stones. So everything, every content we are changing over time, once again based on the game, it has to be stored anywhere, or we need to have access from anywhere. So if we save that scene now, everything will be saved wherever it is. Like if that are going to be prefabs, if needed, then these prefabs are going to be at this position. They always start here. Whenever we are loading this game, they always start here whenever we have saved it so as this particular setup in the scene. Yeah, once again, we want to now save this information of the current position of these three stones into some kind of script, or actually in that binary file. So I create a script. I call it maybe save load. You can name it whatever you like and please, once again. And open this one up in Mono Develop or Visual Studio, but just by double clicking it. It's of type C#, so that's what I always do. I always write my scripts in C#. So what we're gonna need to do is at first we need to create two functions. Probably we keep start. We don't need update here, so we can get rid of it. So what we need is we need two functions for saving and loading. Let's start with saving. So it's of type void, probably, or no, it needs to be public, so we can access it later on from a button, for example, or from wherever we like to. So we can press that button and initialize that saving process. We can also make save load an instance so we can easier access this from any point in the game, like when you go onto a teleportation platform or on a safe spot, that you are able to trigger this function. Maybe we're gonna go over that, but actually it's nothing fancy at all. It's just a, okay, this is triggered, please do the saving for me, and then we just talk to the save load script directly. You can even go and make everything static, but this will complicate the process even more. Okay, so, well, at least for the moment, for explaining what is going on. Okay, so we have a public void save. Whenever we want to save, we need to, at first, I'm gonna do some commands here so you can maybe understand it better. At first, we need to create a data holder and fill it. A data holder and fill it. So the data holder will be just an empty class. We're going to put all our necessary informations into that, and then we save that complete data file, that data class, to serialize that. And later on, we're going to deserialize that in loading, but that's what we're going to do next. Okay, so we create a data holder and fill that data holder. So, and whenever we are done, like when we have all relevant data, so then we get all relevant data at this point, or it's basically the same as filling it. And the next one is you probably want to say, okay, we're gonna do the saving over here, do saving. I guess we're gonna start with that saving now. And we're gonna create the relevant data container next step. No, we do it vice versa. We're gonna create that class first. Okay, so we create a new public class inside our save load class, and I can call it maybe save data. In save data, we can put in any necessary information. At the moment, we just need the information about the cubes, but we don't want to talk to, or we cannot, this is important, we cannot store the complete game object with all its components. We only want to make sure that we get necessary data. This is important because you cannot serialize objects like game objects or everything which is based on game objects or object type in the Unity engine. We cannot serialize them. That will be just, it just won't work because there are so many components. Like alone on one stone we have like the transform component, the cube mesh, the mesh renderer, the box, and the material. We don't need to save all that unnecessary data. We just need to know where is that cube at. So once again, it is super important that you only store relevant data. If you have something like an inventory system or equipment which is currently on your character, make use of an ID system and just store that IDs. And later on, you pick from your inventory or from your database where all your items are inside and only put the IDs back into the character whenever you're loading the scene. So this is super important. There are several workarounds, several systems, and so on and so forth, because we can only store yeah, like floats, strings, integer, and I guess even boolean. That's everything we can save in this binary data class or binary file. We cannot save a vector. Well, not directly. We need to split it apart. So we can only take those basic informations, like once again, integers, floats, strings, and boolean. And we can also use arrays and lists, I believe, meaning we can even store a list, but even that list and everything containing inside that list can only be of type float, string, integer, and boolean. Once again, arrays are allowed. I'm not sure about enums, but arrays and lists should work 100%, as long as they only contain data which are, once again, of these four types. So we want to save the relevant data, so we need to define first what do we want to save. And what we want to save is actually from every game object we're gonna have in our game manager class, like in this list, we want to get like all the stones and we want to have all its vector positions or transform positions, like on the x-axis, the y-axis, and the z-axis. And all of these can only be stored as float or You can also create a long string, but you need to split that string later on apart to send the data back to this game objects. So that's what we're going to talk about later on as well. So what we can do is we can take, like, for every game object, we take all these three floats, like the x, y, and z axis, and bring them into the save data class so we can store it. But we can also say we only want to store a list of, a specific type, which has all this relevant data. For example, we can even create another class which is containing and getting these, and we're going to put them into an array, or in this case, into a list, which we're going to drag or put into the save data class. So as you see, this is a huge amount of work we need to do and prepare everything before we are actually able to save stuff. But once you get used to it, you are absolutely good to go. Okay, I gonna think about how we can design that right now so it makes way more sense. We can, um, yeah, since we have several different ones, I believe we're gonna create an extra class inside the save data class, public class, let's say stone info. And in stone info, we have three floats. Float x POS, so the x position of the game object. Then we can also have a y and a z axis. In 3D and 2D, you just need x and y. In 3D, we're gonna use that. So what we can now do is we can put this stone info into a list and let it fill automatically whenever we are filling that data. And what we're gonna do is we create a list in the save data class, which is containing as much as we need. Like if we have 10 stones, then we can also put them into. So it's going to be, I don't even think, yeah, I believe we need to make it public anyways, even if it contains it here. So we make not a class, but a list. Open close parentheses, and this is of type stone info. And stone info is going to be the stone info list. We need to put all the data into that list inside the save data class. Basically not important if we have stone info in here as well. We say, okay, it's a new list of type stone info, open close parentheses, close the line with a semicolon. The save data class itself needs to be marked as serializable. So we say system.serializable. And I believe the stone info class needs to have that as well. Otherwise, we don't see or maybe have no info which contains all of that connection. So we say system.serializable here as well. So we need to be able to serialize, like to store and access these classes from anywhere we like to. Okay, so now we have an info list. We have a stone info class, which contains later on the X, Y, and Z position of the stones. Now we just need to fill it and save this particular data into the stone info list. And later on we get back and bring the info back inside the stone info list. And after we are done with even that, we're going to push that new or loaded data back into the game manager. Okay, so at first we create a new data holder and fill it. Okay, so let's create that data holder. We're gonna create a new save data class. We name it data or whatever you please is equal to a new save data class. Open close parentheses, close the line with a semicolon. So we have now an accessor named data where we can push data into. Let me make some space over here. First, we need to have access to the game manager as well. So we're gonna have several possibilities. We can for example, we can make the game manager pretty quick static, so we can access it just by an instance, basically. So we say public game manager, I call it instance. And that's pretty much it. Instead of a start, I'm gonna make use of awake. I don't go over singleton design pattern and stuff like that, so I just want to make sure we have easy access. So we say in awake instance is equal to this. So we say this is just an instant of that. I'm not sure. Oh, it needs to be a static one. That's what's missing here. This needs to be marked as static, otherwise it doesn't work. And now in save load, don't forget to save in between, by the way. In save load, probably in start or even awake or wherever. No, we don't even need to catch that data, but we can make use of it right now over here. Okay, so what do we want to do is we want to go and loop through the game manager, this public stone list, and get all its information and put this into the stone list info, which is of type stone info, and store X, Y, and Z. So we need to loop through that anyhow. So we can make a for each, we can make a for loop, whatever you please and like, and you can do this with a lot of different content. So what is the maximum over here? By the way, if you type for and tap twice, you're gonna get automatically created that for loop. So what do we want to loop through is the game manager dot instance dot, and in here we should have, whoops, we should have a stone list, I believe. Let's see. Stone list. It's a public one, should be accessible for us. So stone list, it doesn't let me. Maybe I need to save something somewhere. Gonna copy that name pretty quick. Maybe I forgot something. I don't know. We will see in just a sec. Stonelist.count. I'm gonna save that and rather quickly check if Unity has any problem with whatever I've written so far. Game manager to Unity game object type. Let's see. Okay, that's strange. Oh, yeah, of course. This is not game object, this is a game manager over here. We create an instance of the game manager, not a game object. So keep that in mind. So now we should have full access to the game manager and everything else should be gone over here, like all these errors, just in case. Checking that. Yeah, looks good. Okay, so we can now loop through inside the game manager instance. We loop through the stone list for this particular level through its maximum amount, and now we take all the infos while we are looping through and put them into the stone info list. So we can say stone. No, it is like in the data. So data, which is going to be our data holder, data.stoneinfo_list, and now we can put in new types, like we can create a new class and filling that. So dot add, and what do we want to add is, as you can see, save data stone info item. So this is going to be this item which is related or currently inside save data. If you don't like that, you can absolutely also go into that and take the stone class over here and bring this outside of the data class. Basically, it doesn't really matter. So what it again says is save data. It told us to say save data dot stone info. So this is the class, and inside that class we should anyhow have access to everything. Let me check that pretty quick. Probably we need to create a new save data stone info class. Oh, we don't have any. We don't have any. How do we do that? Okay, now we're gonna do this a bit different. Probably I'm gonna take this outside of the save data class as an extra one. It still works, but this is not accessible. Since I have no constructor for that, we're gonna do it a bit different. So we maybe want to, per iteration, we want to add a new stone info. I just create stone info is equal to a new stone info. And info dot, and now we should be, oh no, we don't have access because they're not public. Oh my god, I was wondering. So these needs to be public here as well. Copy, paste. Or we need to set up getters and setters so we can keep them private, but Yeah, that's what you need to do. So I'm gonna save that as well. I don't know why that is red now, but probably because I have like two open ends here. I'm gonna delete this pretty quick. Gonna write this again. So now I have access to info, and now I can set x position is equal to, and now we're gonna take the game managers. So wherever we are currently looping through, game manager.instance dot stone list in square brackets I. So we're gonna take the currently looped through item, then we're gonna take the game objects transform dot, and then we can take the position dot x. So we're gonna take the single x position and bring this into our stone info class over here. Copy that and do the same for the y and the z axis. Copy that 2 times. So in here I want to put a y. This here is going to be a z, and the ones in the end need to be y and that as well. So now we can actually save all the positions into the into the info one, and now we bring that data, that info class, into our stone info list. So we say stone info list. Nope, not this one, the other one. Gonna copy that. Stone info list dot add, and what do we want to add? I don't know what the problem once again is. What we want to add is info, and there seemed to be a typo here. Save. Oh, because it is inside the data. So data.stoneinfo.add info. Okay, so now we have the data class, which gets filled with all informations about the game objects positions x, y, and z. X, y, okay, this is y, and this needs to be z, like so. And now we add this into the data container we have created over here. And now we can save whenever everything is done, everything has been looped through, like all 3 stones have been added. We're gonna put and take this info now and do the actual saving. Okay, so how do we do that? At first, we need a binary formatter. But as you can see, as I start typing, binary formatter is not accessible for us because we need to have a specific namespace. So I'm gonna type it here. So if you are writing a binary formatter like that, you can right click on that name and resolve. And as you can see, it needs the using system runtime serialization formatters binary namespace. This one over here is needed. Otherwise, it's not working. So we need to have access to that. Also, we need to have write access. So which is going to be system .io, so input output. So we are actually able to write in onto the system wherever we are currently at. Okay, so when you have that, so once again, system runtime serialization format as binary as well as system.io for write access. So we create a new binary formatter. We can name it whatever we want, bin or binary or BF or whatever. And it's going to be a new binary formatter, open close parentheses, close the line with a semicolon. And we need a file stream where we can actually write into data. So file stream is a new stream over here. And we say this is equal to a new file stream. And there's a constructor for that already, which says, okay, what's the path where we want to store that? Of course, we want it to save related to our game, for example, or wherever our game currently is located, as well as the file mode. Like, do we want to create one? Do we want to overwrite or whatever? There are several possibilities in that mode. We just want to create a new file, or in this case, a new file stream. So what we're going to do is we at first say we want to take application dot persistent data path. That's the path where the app or the game is going to be located. Then we say plus, and now we can add a name for our save file. For example, you can name it blah blah blah. You can name it once again whatever you want. I can name it maybe save file, and then you can give it also an end, an ending, what type of a save file this is going to be. It can be bin, it can be dead, it can be your mother, it can be, you know, a gummy bear, and you can also name it Octo or Octoman or whatever. I can type anything I want as this one. I just need to remember this later on when we are loading the data back. So we now create the file with a save file name.octo. And what we now want to do is we want to set the file stream mode or the file mode. And as you can see, it's append, create, open or create, or just create, whatever you please and like. We can also say open or create. Basically, it doesn't matter. Create should be good to go over here. We are saving, so we are overriding usually the existing file. If we are using open or create, it can also try to open it and write into the existing ones, I guess. So then we need to serialize that file stream. So we can say bin dot. Now we need to serialize that. Serialize, open close parentheses, and now where do we want to serialize? It is inside the stream, comma, and then what do we want to serialize? In this case, it's data. So our save data class, we have filled with all necessary information. Okay, so this is, we're gonna serialize the binary formatter file with or from the stream. So we know, okay, this is where the file goes. It has this file name and we create that. So we serialize that with the data we want to serialize. You can also put in blank list and stuff. There are several possibilities for that as well. Once we are done, we want to close the stream because we don't need it. This is important. So stream.close. And I guess we can also put a debug line here, by the way. So debug.log, where we can say saved or game saved, whatever. Okay, so this is basically everything. The plain saving is just that. But the complete data collection of all informations you need for your game has to go at first into some kind of data or placeholder, I would say. Now I just have only that, but if you have like a time, you want like the current playtime, for example, or whatever integer or float or double or whatever it is, you need to put this at first, or the best way it is, you put it into the data class, then you grab the data after you have created a new instance of that save data class. And once you're done with collecting every necessary data, you just do that saving. And as you can see, this is not the most point here or the hardest stuff. This data collection is going to be the hardest stuff at all. Okay, so whenever you are done with saving, we can actually try to trigger that to see if we have any problems. For example, we can build in some buttons pretty quick and connect the save load script and its functionality directly to our game. Let me pretty quick create a canvas so we can easier or faster use buttons and stuff. Make sure you have an event system set up, and I create a new UI button. And it's maybe going to be my save button. And in text, I want to say, not this one, but this one. I want to say, okay, save the game or just save. So wherever you want to save and however you want to access it is absolutely up to you. I'm gonna go to 2D mode and position this one in the top right corner so I can find it easier and better. Just place this over here so I can later on just touch that button. Now what we need to have is a save load script somewhere in our scene. So since we haven't created this one as a static one, so probably you want to put it directly on the game manager if you want to, or you're going to create a new empty, it doesn't really matter, and name this one maybe save manager, whatever. And what you just take is the save load script and put this directly onto the save manager. And you need to make sure it is somewhere in the scene. Doesn't really matter where. You can also create a prefab out of that and easily drag that, or you can make this persistent through all the scenes, up to you. But once again, this is nothing fancy. So when I now press play and hit save, I should have all the infos stored inside that button. So let me press that. Nothing happens, not even that stuff because we need to set up the on-click event onto the button, of course. So what we need to drag in is the save manager game object here and set save load save. And now we can try again. So this button works now. And we can press on that and we should get a debug line like in the end, okay, game has been saved, which is good. And we can also try to find this object, the save file.octo, somewhere on our computer. I'm gonna make a quick search for that. Meanwhile, we are going through that because I have no idea where this is going to land. So probably it's somewhere wherever the project is going to be, or wherever, I don't know. I try to find it. Meanwhile, save load.octo. And meanwhile, my system is searching for that. We can go forward and create the load function. So loading is nothing more than that. Some lines of code in here. It is more like how do we get the data back where it came from, or where we want to have that. Okay, so let's get into this. I create another public void load data, or load. How do we name that? No, just load. You can name it once again whatever you like and please. Okay, and for loading, we basically do it first. We need to find out if that file, that save file, even exists. Otherwise, we just return and let the stuff go. Or we just give out an error, something like no save game found or something like that. So what we need to do is at first, of course, we need to check that. So if file.exists, and what we need to do is we need to check the path where we want to look at it or for it is application.persistent data path. So basically what we have done so far. And we say plus, and in quotes, we're gonna basically do the same here. We look for file or save file dot octo. Make sure it's 100% correctly written. And if you are unsure if that is correct, just copy paste that all over the place here. So if that only if that file exists, we can do loading. So do loading. Here it is different. Here we create the data holder first, and then we put the data back where it comes from. In this case, we're gonna at first read everything from the stream and deserialize everything inside our, maybe in our stone info list, and bring this back. By the way, maybe we wanna, no, we don't need to, that's cool. So we want to bring this data back into maybe the stone info list, or we bring it directly into the game manager so we can set all the stone list info back where it has to be. So probably we create a little helper function inside the game manager for taking all that infos back into where it came from. So we're gonna do the loading in here if the file is existing, otherwise we just don't, and we can say over here else no file found or something. Debug.log open close parentheses no save file found. Once again, you can bring in any error messages in here for the player, whatever. It's up to you. So what we want to create is a new instance of binary formatter, since we need to read from somewhere and we need to deserialize using that binary formatter. Once again, you can name it whatever you like. I name it once again bin is equal to a new instance of a binary formatter. Open close parentheses, close the line with a semicolon. Now we want to read the file stream again. So we say file stream, or actually we need a new one to read that data from, or wherever the path is and whatever the stream is going to be about, is equal to a new file stream. And once again, we're going to put in the complete same path, application dot persistent data path plus, and then once again in quotes, we're going to put the file name, save file. I believe you can even create new folders if you like to, but that's what you need to do differently whenever you start to save the first time. But for now, it's just not important. And what you can also say, comma, and the next one is going to be the file mode is going to be open because we want to read the data from that. Okay, so now we are having basically everything. We opened the file stream and the stream for the binary formatter. Now what we need to do is we now we can actually already close the stream if we like to. So we can say stream dot close. Open close parentheses, close the line with a semicolon. So we have basically we read everything. Before I want to close the stream, even if I don't think that is anyhow necessary to close the stream at the very end, we should be able to close the stream even before we are passing back the data. So we're gonna say passing back data. So how can we do that? Actually, we need to talk once again to the game manager. We have a static instance which we can talk to, and we have a stone list where we can literally loop through all the game objects and set them to the correct positions we want to give them. So what do we do with that is actually we can loop through all of them and also loop through our stone info class, which is related to the save data class, and bring this back to wherever it come from. Since this is a list type, we probably need to confirm or bring that a bit different. I don't know. We just test it out. So what do we want to do is we want to bring that list from our data stream into the other list on the other side. So we create probably at first a new save data. I'm not sure. Call it data is going to be an equal a new save data class like this. And somehow I need to check that pretty quick. Will this be saved in the channel? Oh yes, this stream will be changed in the saved in the channel. So later on you can even look through that complete stream if you like to. So no problems with that. We need to load the data back into the save data class. So currently I am a bit confused. Sorry for that. So let me check my notes. I haven't even found the file yet, which we have stored before. So how do we load that back, that save data class? Let me pretty quickly check something. I'm gonna be back in just a moment for you, so no problems with that. Everything is a bit slow here. Sorry for that. Oh yeah, we need to deserialize the data or bring the data now into this newly created save data class, of course. Yeah, I forgot about that. So what we need to do is we need to deserialize the binary now inside that. So we say at first we need to typecast. Whoops, we don't create new save data here. We need to say at first we typecast this one into a save data file, and then we're gonna say we want to take the binary stream or the binary formatter dot, and now we want to deserialize that information which is inside from the stream we are currently going through, this one. So now everything should be saved back in a new instance of data class. We shouldn't have any problem, by the way, in the Unity or in Unity itself. So just make sure you check out everything if the compiler has any problems or stuff, but looks good so far. So we're gonna pass back now the data from this data structure or from this data placeholder into Yes, thanks for saying unserializing that. Yeah, deserializing. Yeah, that's what we need to do. Thanks again. And now we can pass this data from the data structure over here to the game manager as well. So, whoops, solution. And basically pass this all over. So we can now loop through like any content, like to or throw both lists at the same time and bring the data back. So basically it doesn't, I guess, doesn't really matter which one we are looping through. So we can make a for loop for this. So for int I equal that. Let's take the game manager again. So game manager.instance.stonelist.count. So whatever the amount of that is going to be looped through. Now we take everything from that and put them into, or let's say from the save data list inside the game manager list. So we can bring that, yeah, inside the list, of course. So we take data dot, and in here we have the stone list info. And what we now can do is we can take I as an indicator, dot, and in here we have, as you can see, position X, Y, and Z, and we can now bring them back to the game manager wherever where we are taking this from. So we can, but we don't want to set this in here. We want to set this into the game manager, so we need to talk to the game manager first. So because we want to set this back to that. Hi, Alex. So game manager.instance.stonelist in square brackets I. Then we go to the transform.x and set this one to be equal to the currently looped through, or as a currently looped through indicator. So data.info or stone info list I dot xpus. So this is the one which is stored inside over there. In here we need to have position, of course. Position.x. And we're gonna do that for all iterations for all our stones. So I copy that 3 times, bring this here. We're gonna take here the Y position and the Z position, and we're gonna take that info from the Y value and from the Z value. Then we are closing the stream. Don't forget to save, of course, and that should be everything we need to do over here. So we are looping through the game manager list, put in all the necessary data to the transform position inside that game object, which we have stored in the data container beforehand. And now we should be able to even load that, even if we are changing some things inside the game meanwhile it's running, and call this load function from that. Let me save everything. Let's see if the compiler has any problems with that. Probably not. Maybe we need to put it somewhere in a temporary position, it seems. So maybe we want to create a new vector for that. So vector3 new, or POS, I don't know, is equal to a new vector3 open close parentheses, and now we need to put in like all this information back to or from that over here. So at first we're gonna take this, we're gonna store that data dot position X, then the position Y, comma, then the position Z, like this. So we store that in a new vector basically, and now we can get rid of all these 2 lines because it doesn't let us otherwise doing so. And we're gonna say transform.position is equal to POS. So let's see if he likes that even better. You're welcome, Alex. I guess you have been the one which has requested that. So as you can see now, the error messages have been gone. Oh, okay. I don't know PHP, so I cannot help you with that. Sorry about. this. So now once again we have a vector which is storing all the data from the data container, and then we push that back as one line of code into whatever the objects are going to be about. Okay, so now we have that, so we need another button to load our data, right? So we create a new button, somewhere in UI button, or we can, maybe we just duplicate this one over here. I rename this one to load, give it another text, load, doesn't need to have that. And we need to have a different on-click event on the button itself. So if we take it from Save Manager, but we're gonna need to load the load function over here and put this over there. Okay, so now we should be able to, in play mode, should be able to read from the saved data and load it back. For example, if I go to 3D mode again and go to one of my stones, and let's say I move it, like I move it here. What I would do is, or what probably happens is, whenever I'm loading now, it should pop back where it came from. As you can see, it has been loaded back to its original position. We can test this with all the other two stones as well. We're gonna bring that here because we have already stored a file, and we can bring that, I don't know, over there. And whenever we are pressing load, everything is back to its original position because we have that saved data already created beforehand. So and that's basically everything you need to know about saving and storing data. The the hardest part is like passing all the data back to wherever it came from, as well as how to store or how to create the data holder and get all necessary, once again, all necessary information to that. Hi Code Anima. Yes, this video or this tutorial will be um, this tutorial will be accessible on my channel, so feel free to subscribe and check it out later. I guess it's going to be instantly available after the stream has been done. I don't know Stardew Valley, so probably you find somebody else. I have no idea about this game, so maybe I check it out later on, but at the moment I'm just too busy with other stuff. So, maybe I'm gonna make some more tutorials about different game types and stuff like that. By the way, I have some full game tutorials on Udemy, so if you're interested on these courses, feel free to go there. It's udemy.com/, user/Octoman. That's where all my courses are going to be. Okay, so now we close the stream. It's important that you do that. And we have not, actually the save file has not been found. Well, this error message does not appear. Let me try to find, anyhow, it doesn't seem that that I have that save file anywhere on my computer. So the system does know where it is, but my computer doesn't know where it is. That's so funny. So I tried to find it, or tried already to find this so I can show you what this file is going to be about. But actually, it doesn't find it. Funny. Maybe I have it on my desktop. I have no idea. Um, hmm. Maybe I try to find it again in my C drive. Gonna do a quick save again. Maybe we are lucky and we can check out how this save file in the end is going to look. By the way, those binary formats or that files are not working in the web. So if you are trying to actually publish something in web, you shouldn't stick to the binary format because this is you cannot save that in web. So when you're creating a what do you mean by log out that path? Yeah, that's what I thought, but actually, I'm not sure. So once again, I tried to find it. Okay, so yeah, I could debug that. You're right. So probably we can do this on load. If the file exists or something, maybe we're gonna do that. So debug. I don't think that is, I mean, I have no idea. Well, let's try. Uh, just say application dot uh, persistent data path plus, or actually just the persistent data path is needed, right? So let's see if that gives us anything. Go out of play mode and try again and see if we get a folder where this is going to be. It seems to be an app data local something, which is unrelated to that. So I press load, and yeah, there's the as you can see, it's in my project, but somehow not related to the desktop, but to the app data local low something. So gonna clear that. Pretty cool. Thanks a lot for that. I meanwhile it found it already here on my other screen. So what I do it, I'm gonna open this one with an editor or something, so we can take a look into this. More apps editor open. Okay, so now I can show you what this file actually looks about. Oh, that's a bit small, right? Yeah, maybe I can make that a bit bigger. Okay, so this is the file we are going to, or which is going to be saved. So as you can see, some of these things here are telling you nothing. So what we're going to have is a save load plus a stone info. That's what we're going to have here as info as indicator. But as you can see, every important data like X position, Y position, we know, okay, these are the ones, we can see them in plain text. But everything else, like what's the actual position, is like crypted, like this one over here. So nobody who has no idea about that can actually go into these files and change them to, for example, where the goal could be, or can manipulate the save data. Well, not the usual way or not the easy way, like you have in the player press where everything is like open to see from any point in the game. So that's the data structure. That's how it looks. Later on, it's going to become, yeah, of course, bigger depending on how many stuff you're going to save into that file. So that's what I wanted to show you. And yeah, once again, this basically concludes everything you need to know about data persistence. Once again, you need somewhere an access to the files you want to save, like once again, floats, ints, bools, and strings. All of these can be stored, and the rest should be done by systems you're creating. Like if you have a quest system, you will probably want to serialize every quest in its current state, which only should contain, once again, of all these four data types. Yeah, a lot of you people are using XML serialization. It's basically the same process. You can also use JSON files, or probably you are creating JSON files, because this binary formats over here are. I'm not sure about the public key token. I'm not sure what does it mean. So probably it's some part of C# directly. I have no idea. Culture. I guess it somehow it has something to do with the assembly C# itself. And really, I have no idea about if it is a public, if it is null or not. I'm really have no idea about that. So here's just a assembly C# version, culture, whatever. Probably you Google them. And once again, these are kind of encrypted already. And if it's not null, I have no idea. But we don't send any of these public key token stuff inside the save load function or in this binary file. So doesn't matter for us. So do you have any other questions about saving and loading over here? I mean, was a long video already, was a long live stream, because there's so much to say about that. There's so much possibilities to store data, bring that back and forth, and basically it's always the same. Once again, data collection is the more important stuff over here. Like, yeah, at first get all that, put this into one holder, let's say, holder class, and bring this into. If you only have one kind of list you want to store, like just a plain list, you can serialize the list directly without having any data class. But you need to deserialize that later on when you're typecasting this not into save data, but into list type of whatever. Yeah, for example, of what do we named it? Stone list. Yeah, probably you can zip that, but you need to unpack that on runtime as well. So at first you need to have something who is zipping that, like meanwhile you're loading and saving. I'm not sure about the file size. Let's see. Oh yeah, it's 581 bytes. That file I showed you before, the binary file. This one. This is 581 bytes at the moment. So yeah, rather small. If you need to zip that, I have no idea if that is even needed. But yeah, up to you if you want to do that, want to invest your time. And that's probably everything you need to know about that. So just create those two functions, get the data, create the file stream and the binary formatter, put everything inside, and of course make sure that you are able to read the data from any point in your game. For example, once again, as we did here as the game manager, who is containing the stones. And so this way we can, yeah, anytime now load and save when we are in play mode, like when we are doing our puzzle here or whatever this is going to be. I'm gonna move them just freely around by snapping them to somewhere. Once again, you can always overwrite that save file, game saved, and you can load back to this point. Or you just change something. Oh no, I made a mistake. La la la. Gonna bring this here. And you load again. Oh no, it was wrong. So this can be implemented. Rather simple. Once again, takes a long time to get all the necessary data. And don't try to store vectors. Don't try to do it with complete game objects once again, because it's absolutely unnecessary data, as well as it's just not possible to store object types. And yeah, that's pretty much it. Thanks a lot for watching, and thanks a lot for tuning into this live stream. If you have any questions, feel free to ask in the comments below. Don't forget to subscribe to the channel if you haven't already, and check out my Udemy courses if you like to, as well as check out my website, octomangames.com, where you can actually also hire me for your game project. So, for example, if you have any trouble, problems, whatever, with your current game, or you need just a helping hand, I am here. I can help you with that. We can, yeah, do some appointment. We can go over Skype, whatever, and yeah, try to fix your problems if you have any, or help you out. Once again, thanks a lot for tuning in, and I hope you enjoyed this one. And yeah, see you in the next tutorial, probably tomorrow at the same time. No idea. We'll see. Bye bye.